we should be able to use that knowledge to now find the area and perimeter of more complex shapes like this, where you're given both two different triangles. So to find the area and perimeter, no matter what, we know we're gonna need to start finding a bunch of these different little facts and little sides of the shape. So let's go ahead and get started down here. So I'm given the 30-degree side. If I remember, the 30-degree side is sort of like x, so I double it for the hypotenuse times the square root of 3 for the 60-degree side. So over here, I know I can double that to get my hypotenuse of 12, and I can multiply that times the square root of 3 to get my 60-degree side. And now up here, we are now switching into a 45-45-degree triangle, and you're given the hypotenuse. So to go from the hypotenuse to just a 45-degree side, you have to do the opposite of what I see up here. That's x times the square root of 2. I need to do the opposite to get down to just x. So I'm going to take 12 divided by the square root of 2. I'm going to rationalize my denominator. I'll get 12 on the square root of 2 over square root of 2 times the square root of 2 is the square root of 4, which is 2. 6 divided by 2 is 6 on the square root of 2. So I know my two sides over here are 6 on the square root of 2 and 6 on the square root of 2. I now have all the information I need to find the area and perimeter. The perimeter is just the distance of the outside of the shape. So if you ran around this shape on a run, how far would you run? So the inside 12 won't be included as it's not on the perimeter, the rim of the shape. So I'm gonna start adding up the sides. I'm gonna have 6 plus 6 on the square root of 3 plus 6 on the square root of 2 plus another 6 on the square root of 2. Now we need to remember, what do like terms look like with radicals? You can only combine like terms that have the same exact number underneath the square root. That 6, there's no other just 6s out there or just numbers, so 6 will come on down. I don't see any other square root of 3s, so 6 on the square root of 3 will come down. But I do see I have 2 batches of square root of 2s. Remember, we're gonna combine this as if it was 6x plus 6x. So I'm gonna combine 6 plus 6 for the 12, but when we do something like 6x plus 6x, we just combine the coefficients. The x's stay the same. So when I do 6 on the square root of 2 plus 6 on the square root of 2, that'll become 12 on the square root of 2. And now these are not like terms, so there's my final answer for the perimeter. The area of this shape is going to be done in 2 parts. We can find the area of our 30, 60, 90 triangle, then the area of the 45, 45, and then we can add them up. The area of a triangle is the base times height divided by 2, and you always know your base and height by the 2 sides that are attached with the 90-degree right angle sign. So for this 30, 60, 90, this is going to be 6 times 6 on the square root of 3 divided by 2. And I'm going to add that with the area of the 45, 45 triangle. I see my right angle, so that tells me the 2 sides I'm multiplying. 6 on the square root of 2 times 6 on the square root of 2 divided by 2. And now I need to simplify down these expressions. Over here, you always do outside numbers together, then radicals together. 6 times 6 is 36. This doesn't have a radical, so that's just going to be the square root of 3 over 2. 36 divided by 2 is 18 on the square root of 3. Now we'll go over here. 6 times 6 is 36. Square root of 2 times square root of 2 is square root of 4. Now, as we know, the square root of 4 is 2. So this is technically 36 times 2. So we're going to end up with 72 over 2. And 72 divided by 2 is 36. These are not like terms because this has a square root of 3, but this doesn't. And so there's our final answer for the area.